Hi guys, how are you? Okay.
Good.
How are you? One second, let me admit it. Okay, I'm thinking of we'll get started with our rate of change. Okay. So yeah, for the theta angle, did you have any questions on the homework? I'm going to give a 20 question test. Okay, not now, but it will be a timed test for 30 minutes. The timed test will be in Google Classroom as a part of your homework. Does that make sense? Make sense? Yep. Okay. So see, we will keep reviewing that angles, okay, radians till we go to unit 3, okay, so that you don't forget as well. So it's so helpful when you go to unit 3, that time you'll know. But for now, to just understand where we are, we will have that 20 question test. The time will be 30 minutes. It will be time crunched, but please do, okay. So before you come for the class next week, I'm just preparing the test. So yeah, I'm just reviewing again, changing the question, all that stuff is going on. But I will definitely give you the test as a part of homework. Okay. Okay. Now let's go ahead with your what to say pre-calc unit 1. Okay, AP pre-calc unit 1. I want to get started. Just give me 1 second. The first one is going to be change in tandem. Okay, let me go ahead and share my whiteboard. What is this, guys? Okay, I got it. Okay, so let's move on with this. Let's see. So first we'll understand a lot about functions that we have already learned most of it, but some are relatively new. Okay, so you should be able to find out independent dependent variables, and you should be able to find out increasing decreasing intervals. Okay, so given this function, just let me know what will be the independent dependent variable first, and after that we'll move on one by one. Okay, so this will just be a review, and then as we move on, you'll get to know more about the characteristics of functions. Okay, so given a function p of t, okay, where t is the number of years since kindergarten and p is the number of Pokemon cards collected. So which will be the independent variable and which will be the dependent variable here? You can either, I think answering in chat will help me understand if all of you are on it. Okay, let's go ahead.
My video is not working. Is it okay if I restart and join?
Sure, ma. Go ahead. Let's see, guys. Just give me 1 second. Somebody's at the door, so give me a minute.
I can go. We're doing rollerblades. Thank you.
Oh, you have to be careful with all
I will.
knee pad ಇರ್ತಂಬು.
I erased something here and it made my brain go wackadoo. Study?
Guys, did you get it? This is easy, right? Yep, I got only 5
Give
answers.
me a
Living
minute to get
variable.
out.
Yep. So we are all good with this, I'm supposing. Okay, these are not hard. Okay. It would be the number of years, Pokemon cards for now. Okay. So I think we are good on this. Okay, this is not a hard one, but let me move on. How about, yes, yeah, you can go. Okay. Side length of a box, volume of a box. If you're given side length of a box, volume of a box, side length will be independent. As independent variable changes, the dependent variable will change. Okay. Now, coming to this, right, I would really like you to tell me which is the increasing, which is a decreasing interval. Let's see. What type of a function is this? Increasing or decreasing? Tell me the decreasing or increasing interval. Given this function, so given this function, give me the decreasing interval. We are going to study about functions. Let me put the title. I just started with unit 1. Okay, given this, right, is it a increasing, decreasing in function? First of all, what type of function is this? Second is the interval in which it is increasing or decreasing. I just want to see whether you remember all this from algebra 2. You can give it in inequality notation or in interval notation. You want me to do once, I will do. But if you don't want, please go ahead and send the answer. So, Chetan, we are just discussing functions. We are just understanding the properties of functions that we learned in algebra 2 for us to move on. Okay. Okay. So, in algebra 2, we already learned, okay, this is a decreasing function because why? This is a decreasing function. We'll put in more terms to it, the different ways of referring to the function. Okay, so let's say this is a point A, this is a point B. I will denote 95 as f of A and 10 as f of B. See, these are different notations that we have not learned before, but then you will be able to understand as we move up. So A, B, there are two different x points. Okay, f of A and f of B are the y points corresponding to A and B. So here this is a decreasing function. When you write the interval, right, you will write it out as using this parenthesis. You will write, remember, no square brackets for increasing decreasing interval is what we learned in algebra 2. Okay, this is not, we are not talking about domain or range. We are talking about increasing decreasing interval. So you will write it out as 1 less than x is less than 5. If it is inequality notation, if it is interval notation, you will write it like this for the decreasing interval. Now you can say that f of A is greater than f of B. That's what it is, right? Y value at A is greater than y value at B. Then that will be the decreasing interval. Suppose if f of A is less than f of B, then this would be the increasing interval. Can I move on? I hope you all understood. Stop me if you did not understand whatever I am referring to. We are just notating it differently and I want you to get used to all these stuff when we are talking about it. Can I move on? Nothing is new till now. Okay, let's see. What next? How about this? Now you can send the same increasing decreasing interval for this graph. Same increasing decreasing interval for a particular graph. And one more. I want to tell you about the decreasing interval. So here, there are two questions on the board. Let's put it out as 1 and 2. Okay, for this one, I want to understand the increasing interval. For this one, I really want to understand the decreasing interval. Yep. No, please don't keep quiet there. There's no point. I did not get many answers, guys. Increasing interval is 0 to infinity. Yeah, really? Yeah. Yeah, I like it for now. Yeah, I like it really. Abhiram, okay. So be 2 to 9. 2 to 9, 5 to 12 is, I like it, but 0 to infinity I have to accept. Okay. 2 to infinity. Okay, Harshika, it can be even 0 to infinity, right, ma? Don't you think so?
Yeah.
Yeah, okay, let's go ahead. Shrikar, are you doing Shrikar? Because I'm not getting any answers from you. That is.
Yeah, I'm sending one.
That's a little, yeah. Always I want your answers, Shrikar. Anybody's I really want to see answers, then only I can proceed. Please don't keep quiet there, then we are not going to continue. That's all. Okay. I'm going to move on. You're doing only easy things. Okay. How about this? Okay, this is good. Okay. Please always use only designated x values. Whatever is given, right? Designated x values you use. Okay. So let's see this one. So this one is okay. Now let's see this one. So there is a function given. Okay. You know what I want? What are the answers I want you to provide? I'll let you know. Hold on. Yep. These are the questions I want you to answer. Let's see. Take your time, but once we are thorough with this, we can move on. On what intervals? Okay, the first question. Okay, guys, this is new. Okay, some of these are really new. As we move through the properties of functions, some of it are really new. You know increasing, you know decreasing, you know zeros of a function, you know y-intercept of a function. But the concave up, concave down is really new. Do you know, have you heard of a concave mirror? Concave mirror or a concave lens? You know this, right? This is the shape. I don't know whether you've studied this in physics. I'm asking you. Have you heard of the concave mirror? No, yes. Anything is okay, guys. I'm just asking. No, okay. Okay, no worries. Okay. So let's see. Remember a cup. Okay, you remember a cup? That's concave up. Make sense? This is the easiest way to remember. A cup is concave up. Cup down is concave down. Makes sense? The shape of a graph. This is the easiest way to remember. If you remember a cup, it's concave up. Okay, why? Why? In physics, concave mirrors are shaped like this. Convex mirrors are shaped like this. Okay, this you learn later then. Okay, this is concave mirror or concave lens. Convex is this. Okay, do you see concave? Concavity, you see this one. This is what is seen here, right? Concave up. See, this is a concave, right? Concave up. This is concave down. Make sense? Okay. So now you know which is concave up and what is this? What is this shape? What is the red color marked shape? Concave up is like a cup. Concave down is the opposite. Right? Downward opening parabola. So here, what is this? The red color marking is concave up or concave down?
Concave up.
Concave up. See, this concave up, concave down is very, very useful as we move on, both in pre-calc as well as AP calc or BC calc. Both it's important, okay? So this is concave up. Good job. So concave down is which one? How about this? Do you see this one? This is concave down. Did you guys get it? Okay, so go ahead and answer these questions. A, B, C, D, E, F. Okay, good. I have a good set of questions, 20 questions for your radians. Let's see. Okay, let me know, guys. If you are getting stuck, you have to let me know, then I'll intervene. Otherwise, I will not. You go ahead with the answers. Let me close this out. Go ahead. If you're stuck, let me know. If you are okay, keep going. Okay, so you all have answers, but I need to go to the answers. Oh wow, I'm checking, guys. This one is okay. Let me see how you all answer. Less than C. Oh wow. What interval it is? A concave up. Really? Concave up is. What did I do? Okay. So basically, okay. It's infinity to b. Okay, that's good. And then graph decreasing. A will equal to E. Equal to E. Fine. Anya, I corrected yours. B, D. Okay. Okay. Harshika, you would want to use union for number C.
Okay, I'll fix that.
No problem at all. Shrikar, great to see your answer, Shrikar. Abhiram, I'm waiting. EF. But zeros of the function. How D is not a zero of the function, right, Abhiram?
Sorry?
Zero of the function, right? Zero of the function is. Wait.
Oh, my bad.
No
Yeah.
problem at all. Okay, as long as you get it, that's fine. X equal to A is only the zero of the function. And one more thing, what I noticed was this one. Oh, C, you corrected it, huh? Yeah. D is on what interval is the graph decreasing? Yeah, B to D. Right? Yep. Sahana, correct, ma. 0 to D, yeah. Okay. B to D, yeah. Sahana, I would say from B to D, ma.
Sorry, that was a typo.
No problem at all. As long as you understand, I'm fine. So B to D, na, the interval on which the graph is decreasing, B comma D. Make sense? So between B to D, right? So you can even write it like this. Inequality or less than X is less than D. Okay. I just want to check a few more, guys. Give me a minute. Yep. So B checked. Ashrita, B to D. Yep, decreasing on B to D zeros. Okay. Avni, correct. Pranav also correct. Can I move on? Yes. So let's move on. You understood this. What will be difficult? We'll do this test prep. Okay, we'll do all of the questions in this. Okay, so this should be good for you guys, but the test prep part we'll do. Okay, how about this? You're going to do all of these questions. Okay, I'll give you 4 questions as part of what we learned. Okay, so let's see. Number 1, number 2, 3, 4. You can use the same graph. 2, 3. You can use the same graph. Okay. You can use the same graph. Okay. Just tell me 1, 2, 3. Question 1, 2, 3. Okay. When we finish this, we can go to the next subtopic. 1, 2, 3. 2 and 3 use the same graph. Let me know if you have issues. Otherwise, move on. Mm-hmm. Did you get it, guys? We'll move on. Okay, we'll move on to the next one. Okay. Okay, so slope we have studied, right? In pre-calc, we'll start calling it as rate of change. After this, we'll go over that. Let's go ahead. I'm waiting. Pranav, the first one is correct. Abhiram, good job. All are correct. Did you all get it, guys? I got several answers. Pranav, that's right. Avni, that's right. Ashruta, that's right. Navneet, Navneet, can you look at the second answer, please, Navneet?
Okay.
Shrikar, that's right. Harshika, that's right. Anya, did you get it, ma?
Yeah.
Sahana, can you check the last answer, ma? Can I move on? I'll just wait for all of you to finish and then I'll move on to correct and then I'll move on. D, C, D should have been your answers. Shall we move on, guys? D, C, D should have been the answer. If you have a question, you have to let me know now. Can I move on? Okay. Let's see. Now, yeah, Navneet, you got it. So be correct. Okay, let's move on. Chetan, you're not able to follow, right, Chetan, because everything is in the form of a diagram, right, Chetan? We are not able to hear you. Yeah, we are not able to hear you.
Can you hear me now?
Yeah.
Yeah, it's kind of difficult to follow. Like,
Okay, let's see. From here, if you're able to follow as well, I'm fine. But concave up, concave down, did you understand? Concave up is like a cup, okay, rising up. Concave down is a parabola coming down. It's concave down. To that
Opens up.
point, if you understand, I'm fine. We can move on. What is that?
If it opens up, it's concave up. If it opens down, it's concave down.
Correct, correct. That's right. Okay, now let's go ahead and try this one. One second, guys. Okay, now we have always talked about slopes in functions, right? So basically, that's the rate of change, right? When you talk about two different points in a graph, right? What is the average rate of change is what we are going to talk about. Always, it's the slope, okay? Delta y by delta x. So very different ways of expressing is what we are going to talk in pre-calc. It's pretty easy, meaning you already know what is slope. The thing is, they give sophisticated names. Instead of the slope, they start telling you about the average rate of change. Let's see. Let's say like there is a graph. Let's say this is point A, point B. This is A, this is B. Okay, yeah. I don't want it to be the same though. Let B be here. B be here. I don't want this, let this be C. See, now this one is f of A, this one is f of B. Now, rate of change. See, we have always talked about miles per gallon, right? Hours per day. So this is what we have done. When you see the word per, right, that means there is a rate of change involved, meaning rate of change or a slope involved, right? So here rate of change will be equal to f of B minus f of A by B minus A. Any questions, guys, in this? This is, see, all the while we were doing slope will be equal to delta y by delta x, change in y by change in x, right? This is exactly the same thing, but we are notating it differently or talking in different words. Can I move on? Okay, now let's go ahead and try this one. Remember the change in y comes first and then change in x comes. Okay, now let's go ahead and try this one. How about this? I'm going to give you a graph. I'm going to give you a table. Okay, in both you should be able to find out the rate of change, average rate of change. Okay, there are 2 points given. I know that's a parabola, but let's see. How about this? This one and this one. Giving you a table, I'm giving you a graph, you're going to find the rate of change. What does a AI companion do? I don't know, guys. Somebody stopped it, that's fine. I don't even. Yeah, so rate of change at two different points is given, then it becomes easy. But if the rate of change at a particular point is given, we are going to shorten the interval so small, that way we'll find the rate of change at that point. Okay, we will go to 3 decimal places. When a rate of change is given, when 2 points are given and rates of change is asked, right, it's very easy. F of B, that is a y value at B minus y value at A divided by x value B minus x value A, right? It's nothing but change in y by change in x. Okay, if they give you 2 different points, it's going to be very easy. Now I have given you 2 different points, right? It's very easy to find out because one is 1, 2, 3, 4, x1, y1, x2, y2, y2 minus y1 divided by x2 minus x1. The same thing applies to a graph or a table. Okay, at times they'll ask you at a particular point. So how do we calculate at a particular point average rate of change? When they ask you given 2 points, it's very easy. That's just the slope. However, on a given interval they're asking, right? Meaning these two intervals 1, 2 and 3, 4. What is the average rate of change between these 2 points? It's very easy. So here you will find out f of 4 minus f of, I'm sorry guys, f of 3 minus f of 1 divided by 3 minus 1. That is your average rate of change. So that would be 4 minus 2 by 2. So 2 by 2, which is 1. This is pretty easy. Whereas 13 to 25 seconds, right? 13, 25. What do? 30 minus 76 divide by 25 minus 13, correct? So this is your average rate of change. It's so easy. Right? So this will be, I think it's a negative value, right? 40, 50, 60, 70, 46. Yep. So minus 23 by 6. Makes sense? So this is very easy. Okay. Now, in this itself, right? One was positive, one was negative. So what do you think about positive and negative rate of change? What does that indicate? Any thoughts? What is a positive rate of change indicative of? One quantity increases, what happens to the other quantity if it is a positive rate of change?
Increases.
Increases. If there is a negative rate of change, one quantity increases, the other quantity
Decreases.
decreases. So let me show you in a linear function that we have already learned, right? See, linear function that we have already learned. We have learned this, we have learned this, okay? This is x, this is y. Here, when you think about it, see, here, think about this point. X value increases. See the y value as well increases. Make sense? Here, when you think about 2 points here, right? X value, this is x1, this is x2, okay? This is y1, this is y2. See what happens in a downward facing. See, this is a negative slope, right? You all know this already, right? So this is a positive slope. Okay, in a positive slope, the x value increases, y value increases. What happens in case of a negative slope graph? X value increases. What happens to y value? y1 to y2, y value decreases. So one value increases, one value decreases, right? So that only gives a negative slope. So here clearly this is negative slope, this is positive slope. So here between those 2 points, 3 and 1, right? 3 and 1, 1 and 3 maybe, 1 and 3, see, this is increasing interval. So that's why the slope is positive. Whereas in this graph, right, clearly it's a negative slope. So between these two, see, 76, 30, it's a decreasing. It's one value increases, one value decreases. Can I move on? Okay, now we have talked about positive and negative slope as well. How about this? I'm going to give you two problems. You're going to find out the average rate of change. Okay, then we'll go to rate of change at a particular point. Okay, find the average rate of change for the given interval. You're going to do two problems here. Okay, so go ahead and do this. Find the average rate of change of the function on the given interval. There are two problems. Okay, the interval is 2 and 5. X value is t here. So 2 and 5. The second one is minus 1 and 2. Let me know guys once you're done. Okay, I gave you algebraic equation, right? Okay, I would like you to do one table. Let's see. At a given point we'll do next, okay? So one table, I really want you to get it. Let's see. If you think it's a little fast, you have to let me know, guys, okay? I like to go this pace, but if you don't want to, I'm fine with slowing down as well. So there are three questions on the board, 1, 2 and 3, okay? This algebraic equations are given as functions. Here there is a table. For each of them, you have to calculate the average rate of change over a given interval. See, average rate of change over a given interval. The interval is huge, 2 to 5, 1 to minus 1 to 2. Here it is 6 to 72. So find out these values, send the answer to me in chat, and we'll move on to finding rate of change at a particular point. Yes, so I'll wait, guys. I'll check your answers, guys. Anya. Oh, nice. Please give it to me as a decimal, ma. Anya, was this the answer to this one?
No.
Okay, for the previous one, right, Amma?
Yeah.
Yeah, Ashrita, that's correct. 6250 with 33, yeah. So, really? Oh, yeah. That's correct. Correct, Ashrita. Anya, is it not negative, ma?
Yeah, my bad.
The last one, right? But where is the answer for 1 and 2? Please go in order, ma. Otherwise, I am losing track. Abhiram, is it not negative? See, don't miss the negative signs, guys. It totally changes the meaning. Second one is right, Abhiram. But what happened, Abhiram? Again, you have given second answer as 17. I don't get. Oh, sorry. Second answer is 2.
Oh, didn't you ask for decimal?
Yeah. Oh, sorry. Thank you. Yes, I understood. I didn't understand, Amma.
No. No, that's fine.
Ritu's mom, tell me. இல்ல கிளாஸ்ல இருக்கேன் சொல்லுங்க இல்லையே அதான் தெரியாது இவரை போய் பார்க்க சொல்லியிருக்கேன் ஓகே இவரும் போயிருக்கார் ஓகே bye. Yeah, guys, I'm sorry. Go ahead. Did you get it? Did you get it? But I didn't get the third answer from Abhiram. Yes, ma, Subi. The third answer is pending. Sahana, the first one is not 3, ma. Harshika, I think that's right, ma. Shrikar, that's right. Avni, that's right. Oh, Akshata did not come, right? Why? I don't know. Okay. Pranav, the third one is a negative one, right? The third one is a negative one, right? See, don't forget the negative ones. Maybe you're not forgetting. You don't know.
I put it on my paper, just like I forgot to take it.
Okay. Is Akshada here? Akshada is not here. I don't know why. Okay, can I move on? Okay, I can tell you the answers, guys. The first one, answer is -4. Second one, the answer is 13 by 6 or 2.166x. The third one, answer is -189.39. -189.39 hair follicles per month. Now let's go ahead and find the rate of change at a particular point. Okay. Rate of change at a particular point. Let me go ahead and give you one or two examples. Okay, for a particular point, what are you going to do? So you will be given just one point, right? You see, always you need to have an interval. So if you are asked for a particular point, there will be a rate of change. So there, how do you determine it? You are going to reduce the interval so much to 3 decimal places. You are going to reduce the interval and find out the rate of change. So you will have 2 points, right? One is, let's say they ask you to find out at x equal to 2. Then you go with x equal to 2 and x equal to 2.001, or you go ahead with 1.999 and 2 and then find the rate of change. So that gives you the rate of change at that particular point, since your interval is so small. Okay, how about this? Yes, ma'am.
What do I tell her?
How about this? There's a problem on the board. F of x equal to ln 2x at x equal to 3. So you have to find the rate of change at that point.
Can you make that bigger?
Yes, absolutely. I can write it down. F of x equal to ln 2x at x equal to 3. Is that okay?
Yes.
Okay, ma. Rate of change. Find the rate of change at point x equal to 3. And there is one test prep question. Test prep questions make you think harder, okay? So let's go ahead. Let's only find this and then go with the test prep question for this. Second one is a little harder. You might have to think a little bit, but first find it. First one, say the answer and then go with the second. Second one makes you think a little bit. Akshita, you're too fast for me. Give me a minute, okay? I'm checking. First one, what did I give you? Ln 2x I gave you, right? That, really, ma? No, Ashrita. Oh, okay. That doesn't work out fine. Navneet, your third answer for the previous one was a negative value, right? You got a
No,
positive
that was just a
value. Did you
silly
understand
mistake.
that? Huh?
That was just a silly mistake. I
Yeah,
got that.
okay. See, I am not bothered with you if you are making a mistake. I'm just wanting to make sure that you understood. That's all. Okay, now, Ashrita, that doesn't seem right. Do you want to check?
Yeah, I'll double check it.
I feel like checking now. What did you use? 2.999 or 3.001?
I used 2.999.
Okay. You want me to check? Let me see. 2.99, if you use, what happens? Something feels wrong. Let me check. What was your answer? 1/3, yeah. 6.33. Something is not right, Abhiram. What did you use? 2.999 or 3.001, Abhiram? Oh, yeah. Okay, something is wrong, guys. I'm going to do it on the board. Okay. Two answers I got both don't match at all. So here, right, I'm going to do it like this. I don't know where is the mistake. I'm not able to find where is the mistake yet. Okay, so at 3, right, I'll take 3 and 3.001. Okay, or I'll take 3 and 2.999. Both I'll do. Okay, so here when you think about it, this is ln 2 times 3.001 minus ln, this one is at 3, right? Oh, at 3. Okay, did I calculate it? Yeah, I think I calculated it right. So 2 times 3. Oh, I made a mistake, I think. Divide by, okay, divide by 0.001. Here ln 2 times 3 minus ln 2.999. I'm sorry, ln 2 times 2.999 minus ln 3 divided by 2.999 minus 3. That would be 0.3 minus 2.999 0.001, right? Divide by whatever you get above. What did you get? I'm checking, guys. I'm putting in the calculator. 3 times okay, 2.999 and 3. 2.999 and 3. And 3. 2.999 and 3. Yeah, Abhiram, I think yours is right, Amma. I'm so sorry. I think yours is right.
It's alright.
For 2 is answer no change. Oh yeah, that's right. Correct, that's right. So what will be the values of B, Abhiram? Your thought process is correct for the second one. Okay, this is what I'm getting, guys. 0.33. This one I'm getting 0.33333. This one I'm getting 0.33333. This one I'll do 3.001, right? 3.001. Divide, okay. So that is also the same thing I'm getting, 0.33333. Can you check your answer, Ashrita?
Yeah, I think I entered it wrong in my calculator. I did the same steps.
Okay, see, entering in the calculator is also a skill, Amma. So here, yeah, ln 2 times 3.001 you're going to enter, minus ln, then you're going to enter 2 times 3 you're going to enter. After that, please don't do this. Please don't divide. You'll have to put a parenthesis here. And then you need to divide by 0.001. Did you do that?
I did both of the lawns individually and then I subtracted them. And then once I finished that, another one step, I divided by 0.001.
Okay, do you want to check once more? I don't want you, meaning I want you to learn whatever.
Yeah, I did it again and I got the same answer. I got the answer you got this time.
Oh, okay, great. Okay, can I move on to the next one? So the answer was this or this. Find the rate of change at point x equal to 3, f of x equal to ln 2x. Ln 2x in parenthesis. So, if they have given only one point, you choose a point that is nearby that, okay? They have given x equal to 3. You choose another point x equal to 3.001 or you choose a point x equal to 2.999. Now, you know change in y by change in x. Change in y between 3 and 2.999 or change in y for 3.001 and 3 divided by change in x is 3 minus 2.999 or 3.001 minus 3. Whatever you do, change in y by change in x. So for a point, if they ask you, you have to find another point which is so near, you reduce the interval so much that you are able to calculate for the rate of change at a particular point. Rate of change at a particular point is instantaneous rate of change. The other way of referring it is instantaneous rate of change that you will study in physics later. Okay, physics and math are so related. Okay, as we move up to pre-calc and calc, more of physics will come. Now, a continuous function f is defined on the closed interval minus 5 is less than x is less than 6 as shown in the graph below. Okay, for how many values of b between minus 5 and 6? They are asking for x values. For how many values of x value, for how many x values is the average rate of change of the function in the given domain equal to 0? When will the average rate of change be 0? So on the interval b comma 5. So let's see. When will the average rate of change be 0? B comma 5, right? Do you see the y values at 5, the y values at 3, the y value at minus 4? When you talk about, see, the average rate of change, let's consider 5, let's consider 3. F of 5 minus f of 3 by 2, right? What is it? This, the change is 0 here, right? The average rate of change is 0 between x equal to 5 and x equal to 3. X equal to 3 and x equal to minus 4, x equal to 3 and x equal to minus 4. What happens here? X equal to 3 is what? Again, the numerator is going to be 0 by 7, which is 0. So average rate of change is 0 when your y values are exactly the same at those x values. So here, when you think about it, they're asking for how many values of b. For how many values of b means where minus 5 is less than b is less than 6. Between this domain, they're asking. So b value can be a minus 4 or a 3 or a 5 between this interval where b is included and 5 is included, right? So I can pick up minus 4, 3, 5. At all these points, When you think about the average rate of change, the average rate of change is 0 because all the y values are the same. Can I move on? Okay, now let's go ahead. 1 second. Yep. Now, okay, you can solve these, but I would like to do one more of this. All these you can do, guys. Let's move on to the next one. Okay, rates of change. The next one is, see, first we discussed change, properties of functions, then change in tandem we discussed, and then we discussed what? We discussed the rate of change in an interval, average rate of change in an interval, then rate of change at a particular point we discussed. Okay, now we'll go to rates of change in linear and quadratic functions. Okay, so what do you think about, let's find out a quadratic function. Let's talk about a quadratic function. Let's talk about a quadratic function. What is a secant? What is a secant line? Do you all remember what is a secant line?
That is 2
You
points.
can shout out, ma. 1 second, guys. What is a secant function? No, what is a secant line? We have studied that in geometry.
It's a line where it makes 1 point. It touches.
Where it touches?
It touches on 2 points.
2 points. What is a tangent line?
Only touches on 1 point.
Exactly. This is the tangent line, just for your review. This is the secant line. Any questions on that? Okay. So now in a parabola, right, average rate of change, this is a quadratic function. Average rate of change is the slope of a secant line. Slope of between these 2 points, right? The average rate of change. Let's say this is A, this is B. Okay, average, this is the same thing that we studied. But this one is, let's say this is f of b, this is f of a. When you think about it, between these 2 points, there is a negative slope, right? So f of b minus f of a divided by b minus a. B minus a is going to be positive, but f of b is smaller than f of a, so this is going to be a negative value. So we'll end up with a negative average rate of change. Can I move on? Okay, let's see. All this seems easy, right? Okay. The rate of change for a linear function is what? The rate of change for a linear function is? The rate of change for a linear function, how would it be? Okay, let's find out. I really want you to find the rate of change, average rate of change for a linear function. How to find it? Let's see. I'll give you one example where you understand the difference between linear and quadratic function. I want a table which can help you understand what I'm saying. Okay. Let's see this one. Okay, how about this? I'll give you this. Y will be equal. I can put it here. I can cut, paste, copy. Wait. Okay. How about this? If I give you this, right? What is the average rate of change in this interval. Again, find out the average rate of change between 7 and 14. 7 interval, right? 14. Yeah. 6 is the interval. So basically I would do 8 and 14. Can we try this one? This is your function. Clearly this is a linear function. Can we try the average rate of change in this interval and in this interval? Can we try that? I just want you to understand something about linear function, and see, now this is where it goes, the ramp goes a little up. Okay, so here the average rate of change is a 5. Similarly, in this interval, f of 14 minus f of 8 by 14 minus 8, which is 6. F of 14 is what? 5 times 14 minus 3 minus 5 times 8 plus 3. So 5 is 22, 5 minus 5, 6, 7 minus 40 by 6. So that gives you to 30. That gives you, here I'll put it here, guys, please. 30 by 6 will be equal to a 5. So do you see the average rate of change over equal length interval of a linear function? What can you say about it? The average rate of change over equal length intervals for a linear function. What can you say about it? What can you say about the average rate of change over equal length intervals of a linear function? Is what?
It stays the same.
Equal.
It's constant. So let's write that down. This is a very important thing. Okay, so average rate of change over equal length intervals. This is an important concept, guys. For a linear function is a constant. Now comes the bigger part. What can you tell about the rate of change of the average rate of change for a linear function? What can you talk about? What can you say about it?
0.
0. Good job. So the rate of, we were able to prove that for equal length intervals in a linear function, the average rate of change is a constant. Okay. Now rate of change of that average rate of change for the same linear function over equal length interval is 0. Any questions here? Any questions here? Okay. Please let me finish that of the quadratic function and then we'll disperse. Okay. So that will be fast. Okay. Let's see. I'm going to take all this off. I'm going to keep the one on top there. So this concept is very important. Let's erase that off. We'll just go to a quadratic function, compare that. Quadratic function is going to be a little different. So let's see a quadratic function. Maybe this one. We'll take this one. We'll take this quadratic function I'll do it, guys, so that will be quicker. Y will be equal to 2x square plus 2x plus 1 in the interval 2 less than or equal to x is less than or equal to 5. The other one I'm going to do is maybe 2 to 5. Maybe I can do, I want a smaller one though. 2 to 5, maybe 5 is less than x is less than or equal to 8. Let's see this one. Okay, so this one, f of 5 is 2, 25 plus 10 plus 1, 50 plus 10 plus 1, which is a 61. F of 2, 2, 4, 4, 1, 8, 9, 10, 11, 12, 13. So now average rate of change is what? 61 minus 13 by 3, which is what? 8. 48 by 3, 116 I'm getting here. Second one, right? Average rate of change f of 8 is 64. 64 times 2 is 128 plus, what did I do? Okay, f of 8, correct, I'm doing it correct, plus 16 plus 1, right? 128 plus 17, which is 145. F of 5, I'm just plugging in, guys, it should be easy on you. 50 plus 10 plus 161. Now 145 minus
Miss Priya, the numbers you're writing right now we can't see.
Oh, why? Okay, okay, so let me do this. You're able to see the intervals, right?
Yeah.
Okay, so for this interval, let me find out and just put it in there. 8. Yep. 84 by 3. 3 to 6. Okay, so here it is 20. You can as well calculate and tell me, guys. 28. So now what are you able to see, Ashrita? You're able to see between 2 to 5, between 5 to 8. Are you able to see the average rate of change?
Yeah.
Average rate of change was, this was 16, this was 28. You're able to see that?
I can see the 20, I couldn't see the 16.
Okay, but on top you're able to see that.
Yeah.
I just plugged in
Yeah.
and found out the slope. Okay, now I'm going to go ahead and find out for another interval. Okay, see, it's not equal, right? But you're going to learn something here. Okay, 8, maybe I will try 9, 10, 11, equal length intervals, right? 9, 10, 11. Let's find out. Okay, how about this? F of 11 will be 121. Oh my god, this is becoming huge. 121 plus 2 times 11, 22 plus 1. So this would be 2, 4, 2 plus 23. This will be a 5. If I make a mistake, you can tell me, guys. 265, and then f of 9 is 9 9s are 81. 81 times 2 is 162 plus 9 2s are 18 plus 1. 18 plus 1, so that is 19. So I'm going to add 19, 11, 1, 8, 181. So that's good. So rate of change will be 261 minus 181 by 3. So that would be yeah, 360. That doesn't make any sense to me. 16 to 28 is 12. Are we doing it right? Can one of you check? 265 minus 181, guys. So that would be 265 minus 181 is 184. So that would be 6. Something feels wrong. I need to verify this. Are we doing it right, guys? Can one of you check what is the average rate of change in this interval? What is the average rate of change in this interval? What is the average rate of change in this interval? Can one of you recheck with me, please? Somewhere something feels wrong. Can one of you check? feel free to let me know where is the mistake as well. 2x square plus 2x plus 1, that's correct. 242 plus 23, 5, 62, 65. F of 9 is 81. 81 times 2 is 162 plus 162 plus 18 plus 1, 19, 1, 6, 171. 265 minus 171 I'm getting, oh my goodness, 4 and then a 9. That changes the equation, guys. 3 3s are 9, 31. Can one of you check? There is something wrong in the last one, I think.
The last one, what do you guess the rate of change?
Yeah, what is the rate of change?
I got 42.
42?
Yeah, I
Yeah.
got 42 too.
42
also
plus
got
1?
42.
Okay,
Nine.
between 5 and 8?
I got 28.
16, 28 and 42, is it?
Yeah, that's what I got.
I think that's good. See,
Yeah.
what do you observe then? If it is 42, that's right. So what do you observe between equal length intervals? See, what happens? 16 and 28, what is the difference? So what do you average rate of change over equal length intervals for a quadratic function? What is it? Average rate of change over equal length intervals for a linear function was a constant. Okay, so here it's not a constant, it changes definitely. Okay, but what can we tell about the rate of change of the average rate of change for a quadratic function? What is the rate of change here? This is a 12 up, right? How about this? How much up is this? Something feels so wrong here. 28, 38. Okay, let you go. We will continue with this next week. We'll continue with the same problem next week. Same function I'll continue from the start. Okay, so basically what we need to get is average rate of change over equal length intervals of a linear function is a constant. So average rate of change for a linear function will be 0. However, for a quadratic function, average rate of change over equal length intervals will change. However, the rate of change of average rate of change for a quadratic function will be a constant. Make sense? Because the second difference is going to be the same. Okay, if you didn't understand this, the rate of change here has to be a constant. So I'll show you that next week. We'll do it slowly. We don't have to hurry like this. I will start from here next week. Any questions? So we will discuss the linear and quadratic functions next week. Okay, slowly with a graph, with a table, and then show how the rate of change of average rate of change changes. Okay guys, I'll stop here. Any questions? Okay, sorry for the rush. We'll do it slowly. Okay, bye guys. Any questions? Please stay and ask.
No, man. Thank you.
Yeah,
I'm
do
fine.
the
Yeah,
test
thank
on
you.
radiance.
Thank you.
Bye, ma. Have a nice week ahead, guys.